So now that you're starting to get a better understanding of trig, inverse trig functions and their domains and their ranges, we're going to go a little bit deeper than we had before. We've previously used them when we're solving for a ratio. We've looked at it when, for example, we were given a right triangle and asked to find a rotation. We said, oh, I'll just take the sine inverse or the cosine inverse or tangent inverse of both sides, and sine and sine inverse or cosine and cosine inverse, tangent and tangent inverse, they cancel. Well, that's not entirely true. Now that we have a little more information about domains and ranges, we'll see why. So if you are taking the sine of sine inverse, cosine of cosine inverse, or tangent of tangent inverse, they do indeed cancel. The reason is the value that your inverse function gives you will always be within the domain of your given trig function, mainly because their domains don't have a lot of restrictions. Other than tangent, who has restrictions wherever we have vertical asymptotes, but my rotation that I get isn't going to be a vertical asymptote, so we don't have to worry about that. So if we're given something that's always right here that's in the domain, then all we have to do is go and find the value. We don't have any restrictions to any area on the circle with sine, cosine, or tangent. However, when we get to sine inverse over here, I do have restrictions. This has to give me an answer between negative pi over 2 and pi over 2. But I do not have to take the sine between negative pi over 2 and pi over 2. For example, I could take the sine value of pi, but these can't cancel because sine inverse cannot give me an answer back of pi. It's not within my range restriction. I could take cosine of 3 pi over 2. However, cosine inverse cannot give me an answer back. These cannot simply cancel to give me 3 pi over 2 because it's not in my domain, or excuse me, my range restriction. So for example, if I take sine of 150, it's 1/2. If I take sine of 30, it's 1/2. But remember, in order for an inverse function to exist, we can't be having that same y value show up more than once. That's why we restricted that function to begin with, so that we didn't have this problem occurring. So then whenever I take sine inverse of 1/2, I have to get 30. I cannot get 150. So in other words, sine inverse of sine of 150 is 30. Sine inverse of sine of 30 is still 30. So if this x value, if what I'm taking my trig function of is within my range of my inverse function, then they'll cancel. If not, my answer is going to have to be whatever rotation gives me that same ratio or same point, but within my range. So let's go ahead and look at some specific examples. So I see on example 1 that sine inverse is asking me for a rotation. So what rotation gives me this point, gives me this y value? Well, that's not on my unit circle, so I can go to my calculator. Except that I notice that whatever this gives me is going to be within the domain of sine. Well, since whatever this gives me is in the domain of sine, and I don't have any restrictions when I'm listing my sine answer, I don't have any range restrictions, as long as my answer is within -1 and 1, and negative pi over 4 is between -1 and 1, these are going to cancel out, and I'm just left with negative pi over 4. It's this first situation here. Notice example 2 is very similar to example 1. I have tangent on the outside. So tangent inverse is going to give me something back that's within my tangent domain. So I can just go ahead and cancel tangent and tangent inverse out, giving me pi over 3. However, when we move into examples 3 through 5, now I have my inverse trig function on the outside. So now I have to be aware, because if the value in here is not within my range restrictions, it's not just going to cancel and give it to me back. So I know that when I take cosine inverse, my range restrictions tell me that my answer that I give back has to be between 0 and pi. Since 5 pi over 4 is not between 0 and pi, cosine inverse and cosine are not simply going to cancel. But 5 pi over 4 is on my unit circle, so I can look up what cosine of 5 pi over 4 is. So I rotate to 5 pi over 4 and I take my x value, and it's going to be negative square root of 2 over 2. So I'll have cosine inverse of negative radical 2 over 2. So then I ask myself, where between 0 and pi do I have, what rotation between 0 and pi do I have a cosine value of negative square root of 2 over 2? And I see that it occurs at a rotation of 3 pi over 4. So even though these didn't cancel out, these aren't equal, they do share the same x value on the unit circle. I'm going to do the same thing with example 4. So again, pi over 3, I notice, is in my range restriction for sine, so I can go ahead and cancel arc, sine, and sine. If I didn't notice that, I can always go to my unit circle and say arc sine of, what is sine of pi over 3? Well, it's square root of 3 over 2. And then if I said, okay, well, how do I find, or what is arc sine of square root of 3 over 2? So in other words, what rotation gives between negative pi over 2 and pi over 2 gives me a value of square root of 3 over 2 for sine, or for y? It is pi over 3. So either way, if you want, you can cancel, or you can always just be safe and go ahead and use the unit circle. Looking at one more example like this, and then we're going to talk about what happens when you have two separate different trig functions. I notice that 2 pi over 3 is not within my range for sine values, or arc sine values, so I'm going to have to go ahead and go to my unit circle and ask myself, when I rotate to 2 pi over 3, what is my sine or my y value? And I notice it's square root of 3 over 2. So now that I have arc sine of square root of 3 over 2, I'm going to ask myself, what rotation between negative pi over 2 and pi over 2 gives me this square root of 3 over 2 value? And I find out it's pi over 3. And so now I have my final answer. Now next thing we want to look at, as I said a moment ago, is what happens if you have two different trig functions. Well, we're either going to use our unit circle, or we're going to draw a right triangle. One thing we're always going to have to be aware of is that the trig inverse or arc trig function, whether it's sine, cosine, tangent, is always going to be talking about a rotation, or being used to find a rotation. A trig function by itself is always going to be talking about a ratio of sides, which we interpret as a point on our unit circle. So when I look at example A here, the first thing I notice is this is referring to some rotation. Let's say it's referring to the rotation of theta. So then I'm trying to find the sine, the ratio or the point, the opposite over hypotenuse of this rotation. When I look at my unit circle, I can't find a rotation that gives me a point of 4 over 5. So I'm going to go ahead and draw a triangle. And I'm just going to put my triangle in the first quadrant since cosine is positive. And I'm going to say some rotation gave me 4 over 5. What is that rotation? Well, I don't really need to know that rotation. I just need to figure out what is sine of that rotation. Well, I can figure out sine of that rotation if I had if I had my opposite side. Well, I notice I can either use Pythagorean's theorem, or notice this is a 3, 4, 5 triangle, and say that my sine of this rotation, sine of cosine inverse of 4 over 5, is just 3 over 5. When I look at the second example here, I notice that this is just a trig function, so sine of pi over 3 should be some ratio or some point. I don't need to draw a triangle in this case because pi over 3 is from my unit circle. So notice I'm really going to have to, in order to be successful on these, I'm really going to have to start paying attention and noticing values that come from my unit circle. I don't have to know their answer or know what they're equivalent to because I can always look it up, but I have to recognize them as a rotation or a value that's coming from the unit circle. So pi over 3, I see the sine value is square root of 3 over 2, so now I have cosine inverse of square root of 3 over 2. So now I ask myself, what rotation, since it's inverse, what rotation gives me radical 3 over 2 between 0 and pi in the cosine or x position? And I see that happens at pi over 6. So what rotation gives me a cosine value of square root of 3 over 2? A rotation of pi over 6. Looking at one final example here, I guess I'll leave that up there. So I have arctangent of 5 pi over 12. So arctangent is a rotation. So I ask myself, what rotation gives me a sine over cosine value of 5 pi over 5 over 12? And I notice that no matter what I do, when I divide sine over cosine, I never get 5 over 12. So that makes me think maybe I can draw a right triangle. And when I draw that right triangle, this is referring to the rotation. I'm going to put it in quadrant 1 since tangent is positive. And I'm going to say that when theta, when the opposite is 5 and the adjacent is 12, could I then find the hypotenuse? Because if I could find the hypotenuse, I could figure out what sine of that rotation is, sine of that theta is. Well, I go ahead and I go through Pythagorean theorem, and I see that that's 13. So now looking at this triangle, opposite over hypotenuse is 5 over 13. So big thing again is going to be this idea here. Make sure I know when I'm talking about a rotation versus a ratio or a point. And notice when I can use my unit circle versus when I have to draw a triangle. As well as keep in mind all of your domain restrictions.